In Chapter 9, we're going to be looking at parenteral medications, their labels, and then how to calculate the dosages. Parenteral medications are those that are going to be given sub-Q, IM, IV, One thing you should remember about parenteral medications when you're giving them is typically the single injections are going to be 0.5 to 3 milliliters. So again, if you come up with a dosage that is smaller or larger than that, you're going to want to question yourself and recalculate and make sure that you've calculated that correctly. So let's look at this label. The question is, what is the ratio strength of this solution? And we find that right here, 1 to 1,000. And if you'll remember from Chapter 5, what that means is a 1 to 1,000 strength, which means that there's 1 part drug. This is not working very well. 2, 1 part solution. So that is where we find that on the label. The volume that this is contained in is found right here. It's a 1 milliliter ampule. And then the metric dosage strength of this solution is going to be right here, 1 milligram per 1 milliliter. So what you might have ordered here is possibly 0.5 milliliters of a 1 in 1,000 strength solution. At other times, it's just going to be, your label is just going to be written in metric. And so it will tell you, for example, that there's 50 milligrams per 1 milliliter, or 25 milligrams per 1 milliliter. And that's what we call the metric solution labels. Then you've got things like heparin, which may be measured in international units. And so what you would find there would be a label that says something like 1,000 units per ml. So that would be solutions measured in international units. And you've got examples of those in your book. And finally, you might have solutions that are measured as milliequivalents. And you remember our abbreviation for milliequivalents is M capital E small q. And so in that case, you would have, for example, maybe 5 milliequivalents per ml. Calculating the dosages of these are basically going to be the same. You're just going to have to pay attention to how many milliequivalents are ordered, how many units are ordered, or how many milligrams are ordered. If it's ordered in milliliters, in milliliters, then you need to pay attention to the dosage. Once you've drawn that up, are the milligrams an appropriate dose for that patient? Are the units an appropriate dose for that patient? If it's ordered, say, so many milliliters of a solution that is 1 to 1,000, you have to make sure that you have that particular solution and you're not drawing up 1 to 10,000, because it obviously wouldn't be the same. Okay, here's an example where you have, it's measured in milliequivalents per milliliter. So let me ask you some questions about this particular label. What is the strength of this solution in milliequivalents per milliliter? Hopefully you found this right here. It's 2 milliequivalents per each milliliter. Then, if you were asked to prepare 40 milliequivalents for an addition to an IV solution, what volume would you draw up? So we could use our ordered dose over what we have times our volume again. And our ordered dose would be 40 milliequivalents over, we've got what we have is 2 milliequivalents times 1 ml, because we've got 2 milliequivalents in 1 ml. That would give us 40 over 2, which would give us 20 mLs that we would need to draw up to add to our dose. Okay. Now you might be saying, well, there's not even 20 milliliters in this vial, and there's not. There's only 15 milliliters. And I said before, that would be something that you might think, well, that's too much. Well, we're not giving this as a single injection into a person. Potassium chloride would be added to an IV, must be diluted prior to IV administration, so that would be an appropriate dose. Then our last question about this label would be, what volume would you need for a dosage of 20 milliequivalents? So again, we can use our formula that we used earlier, and our desired dose, or our ordered dose, would be 20 milliequivalents. Let's label it this time, over what we have on hand is going to be our 2 milliequivalents times our volume, which is 1 milliliter, equals, we've got 20 over 2. We can cancel out our milliequivalents, which leaves our milliliter, so that we know that our answer has to be 10 milliliters would be what we would need to administer in order to deliver 20 milliequivalents. Okay, here's another one. It's a little fuzzy, but this one's sodium bicarb, and our question is, what is the dosage strength expressed in milliequivalents per milliliter? And so what we have here is 50 milliequivalents per milliliter. So if there's 50 in 50, that would mean that there's 1 milliequivalent per 1 milliliter. The total volume of the vial is going to be 50 milliliters. And how many milliequivalents does this volume contain? Well, we already decided that there's 1 milliequivalent per 1 milliliter. So if there's 50 milliliters in here, we know that we have 50 milliequivalents, which it tells us right here. So the total number of milliequivalents in this vial is 50. Then the next question is, what is the strength per milliliter expressed as grams? And that answer is going to be each milliliter contains 4.2 grams of sodium bicarb. And if you were asked to prepare 10 milliliters of an 8.4 sodium bicarb solution, what volume would you draw up in a syringe? Well, we can see right here that this is an 8.4% solution. So since it already is that 8.4% solution, we know that we're going to draw up 10 milliliters. We don't have to mix anything. It is an 8.4 solution. We just draw up 10 milliliters. Okay, now on these we're going to do some dosage ordered, and then we're going to mark the syringe where we would have to draw up our medication. The dosage that we have ordered is 10 milligrams. Here's our label, and our label says 20 milligrams per 2 milliliters, or 10 milligrams per milliliter, right here. So let's work it out. Some of you have already figured it out, I know, but let's do it with our formula. Ordered over what we have times our volume. Okay, so what we have ordered is 10 milligrams. What we have on hand is 10 milligrams times 1 milliliter. Cancel out our milligrams. We're left with milliliters. We have 10 over 10, which of course is equal to 1 milliliter. And so where would we draw up our medication to? Whoops, kind of hard to do on here. 1 right here. Right on the line, not below it like I did. And we would draw our medication up to there. Okay, this one is done in international units, and our order for our heparin is going to be 2,500 units. So let's set it up again. What we have ordered is our 2,500 units over our 5,000 units. As we can see here, we have 5,000 units per ml times 1 ml equals. Now let's cancel out some zeros. Cancel out our units, and we end up with 25 over 50 equals 1/2, which is going to equal 0.5 mLs. So we know that we have, looks like a tuberculin syringe here, and so you can see right here the mLs And here's your 0.5 right here. So we would draw up to there. Alright, another one. We've got sodium chloride here. We have got a dosage, now we've got a dosage here of 23.4%. We've got 4 milliequivalents per milliliter, and our ordered dosage is we're to give 40 milliequivalents. So that is our ordered dosage. What we have on hand is 4 milliequivalents per 1 milliliter. So we can cancel out our milliequivalents. We can reduce this fraction. 1 goes into 40 10 times. 10 times 1 is 10. So we would need 10 milliliters to deliver 40 milliequivalents. So we would draw our dosage up to 10 milliliters right here. Okay, so you've probably noticed in your book most of the parenteral medication labels are small. So be very careful in reading those labels. The average IM dose is going to be 0.5 to 3 milliliters. Usually IMs are drawn up in a 3 milliliter syringe. The average sub-Q dose is usually between 0.5 and 1 milliliter. And those are usually prepared either using a 3 milliliter or a tuberculin syringe. If dosages are ordered by percentage or ratio strength, they're typically specified in milliliters. So that is helpful. You have seen that most of the parenteral solutions are either measured in metric, which was the milligrams per milliliter. That could also be micrograms. Ratio, which is the 1 to 1,000. Unit, where you might have 1,000 units to 1 milliliter, or milliequivalent dosages, where you have 20 milliequivalents per 2 mLs, or whatever the case may be. And I think that's pretty much it for Chapter 9.